Hello, this is the second lecture, where we'll explore the components of the OpenDID platform. This session serves as a foundational introduction to help you better understand OmniOne OpenDID. If you follow along step by step, you'll find the basic components easy to grasp. Alright, let's get started. OpenDID is a decentralized digital identity framework, based on W3C standards DID and VC. It's developed as open source, which means anyone can review its structure, contribute to it, and easily integrate it across various environments. With OpenDID, users can store VCs received from trusted institutions in their mobile wallet and submit them to verifiers, allowing them to prove their identity while protecting their privacy. In other words, OpenDID enables a user-centric identity verification process that is both secure and privacy-preserving. Now, let's go through the components of the OpenDID platform one by one. First, let's explain the components of the OpenDID platform. The OpenDID system consists of three key elements: entities, services, and providers. They may sound similar but are actually distinct concepts. So let's clearly sort them out here. To put it simply, a provider is the one who offers services to users. By combining multiple entities together, it's easier to understand with a diagram. An entity is a component within the OpenDID system that performs a specific function. These entities come together to form a service, and several services are then grouped to make up a provider. So in summary, a provider is the final organization that delivers multiple services as a bundle. Next, let me walk you through the overall structure of the OpenDID platform. As you can see in the diagram, OpenDID is largely composed of three layers: the ledger, the server, and the client. The ledger acts as the trusted storage layer. Within the server and client, there are additional key components that make up each part. From here, let's take a closer look at each of these components, one by one. First, let's talk about the TAS. The TA service plays the role of a central administrator within the OpenDID ecosystem. It registers and manages the DIDs and VCs of all entities including issuers, verifiers, and holders on the blockchain. The TAS also acts as an intermediary during VC issuance and verification processes. It helps establish trust among participants and ensures smooth interactions between them. Through this role, the TAS becomes the trust anchor at the center of the entire OpenDID network. It serves as a key system that supports trust across the ecosystem. In addition, the TAS provides two extra features. First, there's the list provider function. This function manages and allows lookup of issuers and verifiers participating in the ecosystem. It helps users quickly identify which organizations are involved. Next, there's the notification provider function. When a major event occurs like issuing or verifying a VC, this function delivers the update in real time to the relevant participants. Next, let's talk about the issuer. An issuer refers to an organization or service that creates and issues a verifiable credential, or VC, based on a user's specific qualification. For example, a university can issue a VC that proves graduation. A company can issue a VC verifying employment status. And a government can issue a VC for a national ID. Next, let's talk about the verifier. A verifier is the party that receives a verifiable presentation, or VP, submitted by the user, and checks the included credentials, known as VCs. For example, financial institutions like banks or credit card companies may receive VCs submitted by users to verify their identity and qualifications. In access control systems, a VP can be used to confirm whether someone has the right to enter. And for online service providers, VCs can be used to verify specific conditions, such as whether the user meets an age requirement. Next, let's go over the CAS. CAS is a component in the OpenDID environment that acts as the server for the client application. It operates as the backend for the certified app installed on the user's device. Its primary role is to handle user registration and management, an essential component in the overall system. CAS is especially responsible for securely processing personal identifiable information, such as C, which falls under P. In addition, CAS generates unique application-specific data needed for token creation. It also plays a role in verifying the authenticity of the certified app by providing its own signature when communicating between the wallet and the server. Next, let's talk about the wallet provider. The wallet provider serves as the server component for mobile wallets in OpenDID. It assigns a unique identifier, a unique ID, to each user's wallet, and handles its registration and management. Additionally, the wallet server ensures that a given wallet is recognized as an official and trustworthy one. It generates proof of authenticity and reliability, such as digital certificates, and provides this information to other components. One important point here is that the system identifies and verifies wallets, not users. Not users. In other words, instead of checking who the user is, it checks whether the wallet itself is trustworthy. Next, let's move on to the CA, also known as the certified app. The certified app belongs to the client side of the system. It is the client application that the user interacts with directly, the one that provides the actual screens and features for users. This app handles practical user-side tasks, such as requesting and submitting credentials, and coordinating token issuance. The certified app also communicates with the CAS, and proves that it is a legitimate certified app, by signing its requests. Next is the mobile wallet. The wallet acts as a secure storage system that runs on the user's device. It safely stores and manages critical information, such as DIDs and verifiable credentials. The mobile wallet is connected to the wallet provider, which helps manage whether the wallet is properly registered and trusted. This wallet is embedded inside the certified app, in the form of an SDK. From the user's perspective, it may feel like a single integrated application. However, the wallet functions as a separate, and very important, component. Next is the holder. As the name suggests, the holder is the owner, the user. It refers to the person who uses the certified app and the mobile wallet. The holder is a central figure in the OpenDID system, handling key actions such as requesting, storing, and submitting identity information. In the end, the holder is the end user, the final participant in the ecosystem. They perform essential tasks like receiving verifiable credentials, and submitting verifiable presentations. You can think of the holder as someone who not only uses both the app and the wallet, but also owns and controls them as a part of their digital identity. So far, we've explored the major components of the OpenDID architecture. Let's take a moment to summarize. First, the TAS is a trust-centered server that registers and manages the DIDs and credentials of each component. The issuer is the organization or service that issues credentials to users. The verifier is the entity that checks the credentials submitted by the user. CAS is the server that registers and manages user information and proves the authenticity of the app. The wallet provider is responsible for registering and managing each wallet's unique ID and status. The certified app and mobile wallet act as the holder, the user, who stores and submits credentials from the user's side. Lastly, there are two components that weren't explained earlier, but are part of the overall architecture. The first is the API gateway. It acts as a relay that allows the certified app to query DID documents on the blockchain. In other words, the certified app can easily access the blockchain through the API gateway. The second is the blockchain itself. It stores DID documents and other related data, so that multiple verifiers can transparently query and validate them. It serves as a decentralized ledger, a foundation of trust for the entire system. Now, let's take a look at how the overall OpenDID process works. It's made up of 5 key steps. First, registering the TAS. Then registering participating entities, followed by registering users, issuing credentials, and finally, submitting those credentials. Let's walk through each step in more detail. First, registering the TAS. This is the very first step in the OpenDID ecosystem. It lays the foundation of trust. Registering the TAS on the blockchain means establishing the trust anchor at the core. Once registered, the TAS is ready to manage all entities within the ecosystem. Next is entity registration. After the TAS, which acts as the starting point of trust, has been registered, service participants like issuers and verifiers are then registered on the blockchain through the TAS. By registering their DIDs via the TAS, they become part of the trusted list of participants. The next step is user registration. Users, who play the most important role as end users in the OpenDID ecosystem, also need to go through a registration process. Through the certified app, they receive their own DID and wallet. These DID are then registered to the blockchain via the TAS, officially making the user a recognized holder. within the OpenDID ecosystem. Next is the issuance phase. With the trust chain formed through the core components of OpenDID, the issuer verifies the user's qualifications and issues a verifiable credential. This VC is stored securely in the user's mobile wallet. Finally, we have the submission phase. The VC stored in the mobile wallet remains secure until needed. When required, the user selects only the relevant information from multiple credentials and submits it as a verifiable presentation to the verifier. The verifier then validates the signature and conditions, decides whether the proof can be trusted, and based on the verification result, provides the necessary service to the user. And that brings us to the end of the second session. I hope this session helped you better understand the key components of the OpenDID platform. In the next session, we'll dive into how trust is established within the OpenDID ecosystem. Thanks for joining me today. I'll see you again in the next one.